Hey everyone, welcome to this video lesson, and we're going to be talking about, well, what you see on the screen now. We've seen that 2 to the 6th power times 2 to the 4th power, that's 2 to the 10th power. We can add those exponents. We've seen that when we're dividing those bases, those same bases, we can subtract the exponents. 2 to the 6th power divided by 2 to the 4th, that's 2 to the 2nd, because I can subtract 6 minus 4. We also know, we've got to be careful about that one. If the bigger power is on the denominator, then my answer is going to end up on the denominator. So 2 to the 4th over 2 to the 6th, that ends up being 1 over 2 squared. But what about something like this? We haven't seen parentheses in the mix yet, and parentheses show up everywhere. So let's see how we deal with this. Well, the rule that you're going to learn in this video is called the power of power properties. And basically what it says is that you can take your exponents when they're separated by parentheses like this, and you can multiply them. That's kind of the definition. That's what it tells us we can do, but why? Well, let's just remind ourselves that exponents just mean to repeat something again and again and again, right? So I'm going to take 4 of those, and I'm going to multiply them together. And that's just 2 to the 6th times 2 to the 6th times 2 to the 6th times 2 to the 6th. And wait a second, aren't I just multiplying the same base now? So this is actually just like this problem now, which I know how to deal with that problem. I can add the exponents. So this is 2 to the 6 plus 6 plus 6 plus 6, and that's 24. But that's the same as just saying 6 times 4, right? And so that's what's really going on here, is that I can rewrite it in terms of the product of powers property. And if I were to do that, then I would see, well, it's the same as if I had just multiplied the exponents to begin with, right? And so if you're going to see work for this, usually it will look something like this. 2 to the power of 6 times 4. And then that can get us our answer, 2 to the power of 24. Sounds like somebody's racing outside my house. I don't know if you heard that or not. But anyways, let's go ahead and see this with another couple examples. All right, we're going to finish up with just a few quick examples. These should be fast. And the power of powers property not only says that we can multiply the exponents, but this is almost like, it's not, by the way, but it's almost like the distributive property for exponents. So what I can do is kind of do something like this. Everything inside of the exponent, everything inside the parentheses gets that exponent of 4. So this is going to be 2 to the power of 4, and this is going to be x to the power of, but wait a second, here's where I get something that already has a power, right? And so this is the real meat of the power of power property, that when you do this quote-unquote distribution, which again, it's not the distributive property, but it's almost like that. So when you do this quote-unquote distribution and you distribute to something that already has a power, well, then that means that you can multiply the power that you already got there, right? And so 2 to the power 4, that's 2 times 2 is 4, times 2 is 8, times 2 is 16. And then 3 times 4 is 12. And so my answer is 16x to the power of 12. Easy. Moving on, we have 4ab squared all to the power of 3. This time, there's not 2 things, there's 3 things. I'm calling them things, I really should call them factors. There's 3 factors inside of these parentheses. Each one of them is going to get this power of 3. The b, however, already has a power, and so we're going to raise 4 to the power of 3, and a to the power of 3, but b already has a power, so we're going to multiply the existing powers. 4 to the power of 3, that's one that we know, it's just 64. A to the power of 3, a cubed, it's just a cubed, but then 2 times 3, that's an operation we can do. This is b to the power of 6. And let's take a look at this one, where it's getting a bit more complicated, but still things can be done in order. First step, get rid of the parentheses, and in order to do that, I need to apply this property. So everything in this set of parentheses gets an exponent of 2. And you know what? It's the same for this set of parentheses. Just so happens that both sets of parentheses has a power of 2 on the outside. So cool. All right, let's see what happens. We get 2 squared. We get g to the power of 2 times 2. The existing 2 gets multiplied by another 2. And I don't need that, times. And h also gets squared. Here's my multiplication symbol. We get 3 squared. Again, g and h this time both have existing powers, so it's going to be g to the power of 3 times 2 and h to the power of 2 times 2. Because g started with a 3 and it got a 2 from the outside, same deal, h started with a 2, 2 from the outside. That's how I'm getting those numbers. And we do the work. We simplify it one step at a time. 2 squared, that's something that we can answer. That's 4. 2 times 2 is g to the power of 4. H squared, not a lot we can do with that yet. 3 squared, that's 9. G to the power of 3 times 2. 3 times 2 is 6. H to the power of 2 times 2, which is 4. And finally, it's just like a product of powers property. I got a 4 and a 6, a 4 and a 9 that can multiply together. That's 36. I had to think about that for a second. We got g to the power of 4 and g to the power of 6. That's g to the power of 10. Because, of course, 10, oh my goodness, 4 plus 6 equals 10. I keep thinking of the answer and saying the answer. Sorry about that. We have h to the power of 2, h to the power of 4. That's h to the power of 6. And so we have simplified our answer. And let's do one last example because we need to look at what if there's a fraction. So let's take a look at that. All right, here we go. Let's take a look at it. If there's a fraction, the same rules apply. Everything inside those parentheses gets one of these exponents. Whether it's numerator or denominator, I'm going to have 9 to the power of 3. A squared to the power of 3, which is just power of 2 times 3. And then b, that's going to have a power of 3 times 3. And so we simplify each piece. 9 to the power of 3, that's 729. 2 times 3 is the exponent of a, that's 6. And 3 times 3 is the exponent of b, that's 9. And so you see, if there's a fraction symbol, no big deal. Everything in the parentheses still gets that outside power, and if there's already a power there, multiply it. That's it. So that is how you deal with something like that, and that's how you apply the power of power property. So hopefully that made sense. Thanks for watching, and I'll see you again next time. Bye-bye.